Okay, in this tutorial, I'm going to be teaching you how a drumlin forms. Now, a drumlin is a really unusual feature because it's, well, geographers aren't completely convinced on how it's formed. So I'm going to show you one of the most common explanations in the formation of a drumlin, and I'm going to use two diagrams to show you this. So you might want to write down a heading, first of all, formation of a drumlin. And if you were to draw a diagram to show the most common way this feature is formed, we'll do this through two diagrams. So the first thing is we want to create the valley floor. So this would typically be a U-shaped valley. So valley floor of U-shaped valley. Okay, now the next step is we're going to put ourselves into an ice age. So let's just put a glacier traveling through this valley. This is a cross-sectional diagram, so I'm going to pop a little arrow just to show direction of movement. So this is our direction of movement. Now we've got no front of the glacier, which is why I've drawn it the way you can see, just as a straight blue line, because it's traveling through the valley. So what I'm also going to put into my diagram, because I need to indicate this, is that what this is. So this is our glacier, okay? Now, I'm now going to add lots of material into my glacier, what we call till. Glacial till is all kinds of rocks and mud and bits of gravel, all different sizes and shapes. Some can be absolutely massive, and some can be very, very small rocks. And glaciers are full of billions of tons of this material that has ended up in the glacier because it's been picked up through plucking, or it's rolled onto the glacier through freeze or weathering off the top of a mountain. And what we've got here is a glacier loaded with glacial till, okay? So that's another key label that I need to add to my diagram, just so we know what this is. As a matter of fact, we would go a little bit further. We would say that the glacier is actually overloaded. That's a key idea. And what I'm trying to stress here, being overloaded with glacial till, is that there's too much in the glacier, and it's struggling to hold on to it. So, and this is a key idea, it starts to deposit some of the till. Now, this is likely to happen towards the end of an ice age when the glacier has actually started to melt and lose some of its energy. Right, I'm now going to add something into on my valley floor, which is one of the most common theories. This is where there's a variety of opinions on this. But if you have a large obstruction of rock on your valley floor, now this would be normally an outcrop of very hard rock, maybe an igneous rock, that the glacier has not managed to erode away in the same way as the surrounding rock. So you've got the similar kind of principle as you have in a number of other features, most famously the crag and tail feature. But which has a sort of similar grounding in how it forms. So what we've got here is a rock or a rock core to our drumlin, or we've not yet drawn our drumlin because it's not formed, but we've got a rock core on the valley floor, uneroded by glacier. It will be eroding, but it won't be eroding as fast because it's going to be a different type of rock, more than likely. Now, what does this mean for our glacier? Well, it means that the till might actually start to accumulate around this rock core, because the rock core acts as a kind of a little windbreak to the glacial material, okay? So I want to add that idea in my diagram. That's what I'm showing is happening in this particular part of my diagram, okay? So let's just add this sediment. Let's put glacier, or glacial, beg your pardon, glacial till accumulating around rock core. And this will take hundreds, if not thousands of years sometimes, as the material gradually passes over and collects especially in the sheltered side of the rock core. Okay, so we've got material gathering, and as the glacier passes overhead, I'm just going to use a different color to show this, because remember, our glacier is passing over, and it's got a huge amount of weight, because these things are massive, these glaciers. What it's actually doing is it starts to mold our glacial till around that rock core. Okay, so I'm just going to add my final label to this diagram, just to, so what these arrows showing? So weight of glacier starts to mold glacial till. Okay, right, that is our during the Ice Age diagram. So I'm going to just indicate we are during Ice Age here. And I'll just pop that over here. Let's move to our after Ice Age. What have we got? Well, we're going to have to put our valley floor in again. And this time we're going to have our glacier, okay? Sorry, not our glacier, I beg your pardon, our drumlin. So we're going to pop our drumlin in. And our drumlin, roughly the same, because I'm doing it directly under the previous diagram that I've drawn. Our drumlin will now have this kind of shape. Okay, and it's going to be comprised of all these different sized, unsorted, unlike the terminal moraine, unlike the esker, I should say, which is, the esker contains lots of sorted rocks because rivers under the glacier sort them into their different sizes. This is all just different sized, okay. We do have our little rock core still in there. And I now need to add a label that shows what have I got. Well, I don't need to tell that red thing is my rock core again, but I do want to show that we have unsorted glacial till. So drumlin comprised of unsorted glacial till. Okay, there we go. So we've got our unsorted glacial till. You'll notice it's got this kind of snubbed side. It's called the stoss slope, so we're going to call it the blunt side. Blunt, and this is a key word you'd want to put into your answer. This is a stoss. Blunt stoss slope, and it faces upstream. So these hills that we see in the landscape, for example, Glasgow's actually built on a whole bunch of them. They've got steep sides, and they are the stoss sides, or the blunt sides, and they face the direction, the upstream direction. So the glacier, remember, was flowing this way. So this front of this hill is actually facing the upstream, as I've just shown you with the arrows. I'm just going to remove them, though. Okay, and as it curves over the top, we get the other hill. So, for example, Sauchiehall Street in Glasgow lies on one of these. This is our gentler slope, and it's got a name. It's called the Lee slope. Okay, the gentle Lee slope, and it faces downstream. Okay. So what else can we say? Well, we can describe our hill. So it's long. It's an elongated and it's oval-shaped hill. Okay, that would be another additional bit of description you could add. One thing we could say is they tell us the direction the glacier moves. So we could add that over here as a sidebar. So they tell us which direction the glacier is moving. Or a glacier moved. That was during the Ice Age. Of course, the glacier's gone, but we can now tell where they moved. We often get many of them together in a valley floor. And that is called a swarm of drumlins. So a lot of U-shaped valleys have a swarm of these little hills all clustered together in the valley floor. Okay. Now you could add a final sidebar. I'll just narrate it to you. You might want to write this down yourself. The alternate theory is these features are actually created by meltwater from the melting glacier. And as glaciers release incredible quantities of meltwater, they actually scour the landscape in front of them and erode it. And then those eroded features then get infilled later on by smaller material, which is why some drumlins show a little bit of sorting. So you could say that that other theories have them being created by the erosion from the meltwater of glaciers. And you would get a credit for acknowledging that there is another theory. Okay, so that is 2 diagrams that show you the processes involved in the formation of a drumlin.